Good afternoon, my YouTube viewers. It is Crystal here. I'm just here because I wanted to do another code review for you. And this code review is going to be on computer vision. And it's going to be on Kaggle's dataset on horses or humans. And I'm going to be using TensorFlow's mobilenet CNN, which is a convolutional neural network. And so basically, I'm still studying, I'm studying as much as I possibly can. I'm getting as much in as I can. And so today I was studying my TensorFlow, but I thought, well, I really need to do a project. I need to do a project and do a blog post on that. So that's why I used Kaggle's horses or humans dataset. And that's what we're going to do. We're going to do the code review. And this code review is a little bit different from code reviews that I have done in the past. And the reason why is because I modified the code review. So I modified the code to try to make it more universal, so you can use the code with any image if you like, and it's already normalized within the model, and I had to do a lot of studying to get it to work, so it wasn't just a matter of copy and pasting from my old data set of lions or cheetahs. I did a little bit of copy and paste, but because it was a different data set and the data set was formatted differently, I had to modify the code. And so that's what this code review is going to be. It's going to be modified code. So the problem statement is identify whether an image is a horse or a human. So it's going to be pretty easy for the computer to do this. And the reason why is because a horse is a lot bigger than a human, and a horse's dimensions are a lot bigger than a human's dimensions. So that makes it a good data set to practice on. Okay, so then what we're going to do is we created this program on Kaggle because it's a free Jupyter notebook on Kaggle, and obviously I don't want to download the files, because if I download the files, then I'm going to use up my memory in my Gmail account, which I don't want to do. So we're doing it all in Kaggle. And what I will do is I will leave a link to the actual notebook in the description box down below so you can look at my notebook, okay? So after we've created the program in Kaggle, then what we're going to do is we're going to import our libraries. So the first libraries that we're going to import are NumPy as NP. That's for your numeric computations, and it also creates NumPy arrays. We're going to import pandas as PD. That's for your data processing, and it also creates data frames and series. We're going to import OS, which goes into the operating system. We're going to import matplotlib.pyplot.splt, which that's your graphical visualization. And we're going to import Seaborn, which is graphical visualization with statistics. And then what we're going to do is we're going to, after we have loaded some of the libraries, we're going to import some of the libraries. We're going to load the files that we're going to use. So we're going to use OS to do that. So for dir name space file names in os.walk kaggle.input. For file name and file names, print os.path.join dir file name. So we've got all these files, all these PNG files. So we're just going to go all the way down to all these PNG files. So there we go. We've gone all the way down. And then what we're going to do is we're going to import pathlib and data dir equals the path that the humans or horses or humans data set is in. So we're going to dir equals pathlib.path data.dir, and then we're going to do data.dir. And so that gives you your pathlib, which you're going to use. So now, after we've got our pathlib, what we're going to do is we're going to list the directory that all of the horses or humans are in. So train horses equals list data dir.globe train horses, train humans equals list data dir.globe trains humans, val horses equals list data dir.globe validation horses, val humans equals list data dir.globe validation humans. And then print length of train horses, you get 500. Print length of train humans, you get 527. Print length of val horses, you get 128. And print length of val humans, you get 128. And so now what we're going to do is we're going to show images of the horses and the humans. So import matplotlib.image as img, import pil.image as image. And so fix ax equals plt subplots, in cause equals 2, in rows equals 1, fig size equals 20, 5, fig.subtitle is category. Rand horses equals np.random.randint. So it's going to be neg1 to len train horses. So that's going to be your give you a random number for your rand horses. And rand humans equals np.random.randint brackets -1, len train humans. And so what that does is that gives you your random number for your humans and the trains. So print rand humans. And then horse image equals img.imread. Train horses, rand horses. Humans image equals img.imread. Train humans, brackets, square brackets, rand humans. Because I didn't like saying, oh, well, pick 0 column. I wanted to add a little bit of flair to the program to make it a random number. So every time you run the program, you have a different random number, and so you get a different picture. And ax0.set titles horses, ax1.set title humans, and then ax0 imshow horses image, ax1 imshow humans image. So we've got our horses and our humans. So that's good. So we see that we got that right. We got horses and our humans right. Okay, now what we're going to do is we're going to separate the images from the labels. So df images equals train horses, train humans, val horses, val humans. And then df labels equals train horses is 0, train humans is 1, val horses is 0, val humans is 1. And then now we import cv2 is img equals cv2.imread string df images train horses, rand horses, and then we're going to convert it to a numerical array. So img.shape is 300, 300, 3. Now we define our x and our y variables. So xy equals brackets for label images in df images.items. For image in images, img equals cv2.imread string image. Resized image equals cf2.resize brackets img 224, 224. x.append resize image, y.append df labels, and then you print length of x and length of y. So let's just see this. The original image was 303, so now we resize it to 224. So you see you have 1283 of x and 1283 of y. So now what we're going to do is we're going to define our x and our y variables. So x equals np.array x. So you're going to convert it to a NumPy array, and y equals np.array y. So you're going to convert that to a NumPy array. And then we split it into training and validation sets and testing sets too. So from sklearn.modelSelection import train test split, xtrain xtest val, ytrain ytest val equals train test split xy, train size equals 80%, random state equals 42, xtest xval ytest yval equals train test split xtest val ytest val, random state 42. Then you check your shape of xtrain, xval, xtest, ytrain, yval, ytest. So you can see you've got 1026 of xtrain, 65 xtest, 65 xval, and 192 xtest. And then so you have the same thing, 1026 y train, 65 y val, and 192 y test. So now what we're going to do is we're going to define our model. So we import our TensorFlow libraries and we check the version of TensorFlow. And it's important to always check the version of TensorFlow because TensorFlow goes through a lot of changes. And because it goes through a lot of changes, it's important to know what version you're using. This is something that I made up. This is normalizer equals tf.keras.layers, rescaling scale equals 1/255. And that's a small piece of code, but it did take me a while to figure it out. So that's code that I made up. And this is your normalizer. And then your mobilenet, because you're using a mobilenet, and then you get the web address for the mobilenet, and then what mobilenet equals hub.keras.layer, mobilenet, comma, input shape is 224 by 224 by 3, trainable equals false. And let's just check something. Yeah, check something here where we reshaped it previously. Okay. And then now what we do is we actually define the model. And then when I define the model, I had to put 2 extra rows, 2 extra layers in there. And that's something that it took me a while to figure out as well. So obviously I used a pre-made model, but I added to it. So this is different from the Cheetahs and Mayans dataset. So num label equals n brackets np.unique y, and that's your number of labels. Model equals keras.sequential, curly, round brackets, square brackets. And then the first layer is keras.input shape is 224, 224, 3. So that's your input. Second layer is normalizer, which we previously defined. The third layer is mobilenet, which we previously defined. And then fourth one is keras.layers.dropout equals 0.2. And the last one is keras.layers.dense equals num label. And then you check your model summary. So this is your model summary. And now what we do is we compile it. So model.compile, optimizer equals atom, loss equals tf.keras.model losses, sparse categorical cross entropy from logics equals true, and metrics equals ACC. And now what we're going to do is we're going to train the model. So we go early stopping equals early stopping, brackets monitor equals val loss, mode equals min, patience equals 25, verbose equals 1, MC equals model checkpoint is brackets best model.h5, so that's saving the model. Monitor equals val loss, mode equals min, save best only equals true, and then history equals model.fit, xtrain, ytrain, epochs equals 100, validation data equals xval, yval, callbacks equals early stopping MC. So we let it iterate through to 100 epochs. And it only gave you, 100 out of 100, so it gave you 100 epochs. And then now what we're going to do is we're going to make predictions. Ypred equals model.predict, xtest, batch equals size equals 64, verbose equals 1, ypred bool equals np.argmax ypred, axis equals 1, and then ypred bool, so you see all these ones and zeros. Now we check the accuracy from sklearn.metrics import accuracy store. Total right equals accuracy score over y test, ypred bool, normalize equals false. Print total right, you got 191. Accuracy equals total right over length y tests. And we print accuracy, so it was 99% accuracy. Now we evaluate, model evaluate, x test, y test. So you get another, we evaluate it. So you have loss of 0.023 and accuracy of 99.48%. Now we do a classification report. So from sklearn.metrics, import classification report, print classification report, y test, ypred bool, precision, and gives you your precision, your recall, your F1 score. And then now what we do is we put it in a confusion matrix. From sklearn.metrics, import confusion matrix. Confusion matrix is y test, ypred bool. So give you 86 zeros and 1 that should have been a 0, and 105 ones. So that was good. And then we create a data frame of the actual values as opposed to the predicted values, and we only got 1 wrong. So now what we do is we create a graph, training and evaluation accuracy at each epoch, so it gives you the accuracy. And then we do another graph of training and evaluation loss at epoch, so you get the loss. So we didn't really need to run it up for 100, we probably could have just run it up for 10. So that's it for this code review. It was slightly different from the cheetahs and lions data set. So I made some modifications on it, tried to improve it. And I will say that because the dimensions of the human are different from the dimensions of the horses, it was easy for the computer, it was easy for the model to pick them out. So this is a good data set to train on. So I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you very much for watching this video. I will leave a link to the notebook in the description box down below. And I look forward to making more code reviews for you in the future.